Konnichiwa, it's Mr. Thompson, and this is a video math lesson. Today we're going to be talking about parallel and perpendicular lines. And some things about parallel and perpendicular lines, using equations, all kinds of fun stuff. First, let's actually define what parallel and perpendicular lines are, just so we're on the same page here. Okay? Parallel lines, to start, are lines that never intersect. Now let's make sure we're very clear about that, okay? I will draw a couple of lines here, okay, that do not intersect, right? As they're drawn, they don't cross, right? But lines go on forever, right? That's why we draw these little arrows at the end of them. And so really we should extend these, right, like so, okay? And we can see that they do cross. So those are not parallel lines, okay? Here are some parallel lines, so that if I extended them on forever, they would still never cross, right? Those are parallel lines. We indicate that lines are parallel by putting little triangles on them, but I am just going to go ahead and get rid of them for now so that it doesn't clutter up the video here. Okay, but those triangles, if you see triangles on a pair of lines like those that I did have there, then you know that they're parallel lines. That's what the information is telling you. So let's explore these parallel lines, okay? Let's look at the slope. All right, that's what we're interested here today. Okay, if we look at this first one, we can go over 3, right? Over 3, 1, 2, 3, and up 1, right? Well, what do you know? If we look at the other one, we can also go over 3 and up 1. Okay, so what we see here is, you know, the slope of this first one is rise over run, so 1/3, and this one, it would be rise over run, 1/3. They have the same gradient, okay? And guess what? That is always true of parallel lines, okay? Parallel lines always have the same gradient, all right? Let's look at perpendicular lines, okay? Here I will draw a couple of perpendicular lines. Perpendicular, unlike parallel, they do intersect, and they intersect at a right angle, 98 degrees, okay? Let's look at the slopes for these ones, okay? We can go down here and go over 2, and that's over 2, or a run of 2, and then we get a rise of 3, right? And let's go to the blue one, and we go, this one, if we start at this point up here, we go down 2, right? So a -2, rise of -2, and a run of +3, okay? So the slope of the green one is 3/2, right? Rise over run. The slope of the blue one is -2 over 3. Rise over run, right? Now, if we can notice a couple of things here. First of all, one of these is negative, okay? And that's always going to be true of perpendicular lines. One's going to be negative, one's going to be positive. Either that or they'll be horizontal and vertical, so it doesn't really apply because the slope of a vertical line is undefined, so this doesn't really work with that anyway. But otherwise, one's always going to be negative, one's always going to be positive. In addition, we can see that both of these slopes have a 3. Okay, one's on the top, one's on the bottom, and they both have a 2, but one's on the top, one's on the bottom. And you can see these are kind of like flipped fractions, right? 3 over 2 and 2 over 3, which are called reciprocals. And since one of them is negative, one of them is positive, we call these numbers negative reciprocals, okay? Where if one is a over b, the other one is negative b over a, right? Okay. Now, one way to check if numbers are negative reciprocals is if you multiply them together. So one times the other. M is a letter we use to represent slopes. So slope of one line times the slope of another. If you multiply two numbers together and they equal -1, then those numbers are negative reciprocals. Okay. So if lines are perpendicular, then their slopes should multiply to -1. Okay. All right, well, fantastic. Well, let's get into this here. If we know they're the same, that parallel lines have the same gradient, and perpendicular lines have negative reciprocal gradient, then we can do something with that, right? We will start by finding an equation of a parallel line, okay? And we're going to do kind of two problems together. A problem might ask you to find the equation for a line, and in this case it says lines parallel to, and they'll give you a rule. So in this case, y equals 2x plus 3, through the points 0, 5, and then also through the point 4, -2. So we're doing two problems here, okay? There's part A and part B, all right? So we'll start with part A. Now, when we're finding an equation, for a new line, one that's parallel to this one and goes through that point, right? Now, in order to write the equation for a line, we need the gradient. Well, we know that the gradient of parallel lines have the same, they are the same, right? They have the same gradient, these two lines. Well, the gradient for this line was 2, right? So that's going to be the gradient for our new equation. Okay, so the gradient is 2, and it's going through the point 0, 5. So we have our gradient, and we also happen to have this point which is on the y-axis. So that's our y-intercept. Okay, and it's obviously really easy from here. We just plug that in to gradient intercept form. Okay, so we plug in the gradient 2, right, and times x plus the y-intercept, which is 5, and that is our equation for the line parallel to this one through that point. Okay, now let's do this one. This one's a little trickier. Okay, we know that the slope is 2. The gradient is 2, right? So it's going to look like this: y equals 2x plus b, but we don't know what this b is yet, right? We don't. This one does not give us a point on the y-axis, so we don't have that y-intercept. It's a little trickier. What we're going to do is plug the x and y in that we do know into this formula and solve for b. So negative 2 goes in for y because it was the y coordinate, right? And then 4 goes in for x plus b, okay? And then we just evaluate this thing. So 2 times 4 is 8. We have the plus b, so negative 2 equals 8 plus b, and then we'll subtract 8 from both sides. Negative, and the 8's cancel out. Negative 2 plus negative 8 is negative 10. Alright, so b equals negative 10, and that is our y-intercept. So now we can plug that in like we did before. Y equals 2 times x plus negative 10. Okay, but to make it look a little nicer, we'll rewrite it as 2x minus 10, and that is our equation. Okay, so that's finding the equation of a parallel line. Now, of course, finding an equation of a perpendicular line. So a problem very similar to the parallel ones. They'll say find an equation for a line perpendicular to a given line through a particular point, right? So we'll do the same thing. We'll do two problems here, and you can sort of see the method of the madness here. Perpendicular to y equals 1/5 x plus 3. And we'll do one line through the point 0, 2, and one line through the point negative 3, 5. Okay, so we'll start with 0, 2, and of course we know that the gradients are going to be negative reciprocals, right? So the gradient for this given line was 1/5, right? So we got to find the negative reciprocal of that. Okay, so we know first of all it's going to be negative, right? Negative reciprocal, so we just go ahead and stick a negative sign on there. If it was negative to begin with, we could just make it positive, right? And then we take 1/5 and we flip it to be 5 over 1. Now 5 over 1 we know is just 5. So our slope, our gradient for our new equations, for those perpendicular lines, is going to have a gradient of negative 5. Okay. Now for the point 0, 2, again we have a nice convenient y-intercept there. That point 0, 2 is on the y-axis. So we can just plug these right in. Y equals negative 5x plus 2. That's it for the first one. Easy, right? Second one, again, as before, it's going to be a little bit tricky. We'll plug in our gradient, negative 5x, and put a b, because we don't know what the y-intercept is yet. This one doesn't give it to us. So we'll plug in the x and the y. Y is 5, given in that coordinate, and x is negative 3. Okay, so we plug those in, plus b. Negative 5 times negative 3 is positive 15. So we get 15 plus b equals 5, right? And then we'll subtract 15 from both sides. And negative, those cancel on the right. And 5 minus 15, or 5 plus negative 15, right, is negative 10. Okay, and didn't even do that on purpose, but we got the same y-intercept both times here. What do you know? Now, we can go ahead and plug that in. That's our y-intercept. So y equals negative 5x minus 10. We'll just skip right to it this time. And there you have it. Good luck, and see you next time.